4.1 day 2, we're talking about random sampling. First big idea. In statistics, what's the key? So, and essentially all your results are going to be rendered invalid unless you've done everything in your power to assure that you sampled it randomly. So everything was done at random. If you can't prove that or provide that, then your results aren't going to be very good and people really aren't going to trust it. So first thing is it has to be random. Just like we saw with the jelly blubber activity, people are not good at just picking representative samples by themselves, although some people did get a pretty good job done. But in general, your results have to be random so we can trust that. So first vocab term today, what's a simple random sample, aka an SRS? And how can you choose an SRS? Well, simple random sample, that's just literally a completely randomized sampling method. So a simple random sample, completely random sample. So essentially, you choose an SRS by, you say draw names out of a hat, or you could use random numbers on your calculator. So nothing special, no tricks, just simple random sample, entirely random. So why would you choose a sample by chance? Okay, so we already said that's the only way people are going to trust your results. So other than that, why would you do it? Well, you got to be fair to everyone. So if you're going to randomly sample a population, you got to be completely fair, meaning every individual has the same chance of being chosen for the sample. Okay, so random sampling, what does that do? It involves a chance process to determine which members of the population are actually included in the sample. So the big take home from this, and we'll use this the entire year, is your stuff's got to be absolutely random when you do a sample. Otherwise, we can't really trust it. All right, so we've already got all this. Let me scroll down here. The definition. What's the definition of an SRS? This is the formal definition. So a simple random sample, we'll call it an SRS for short, is chosen in such a way that every group, so every group possible that you can imagine. If you think back to jelly blubbers, groups of 10, every single possible group of 10 has an equally likely chance to be chosen or to be selected. So if every single possible group of individuals you could think of in the population has an equal chance of being selected, then that's what an SRS is. So for the jelly blubbers, I think there was 100 of them. So every possible group of 10, which believe me, there's a ton of possible groups of 10, but they all have to have a fair chance. So if every group has a fair chance, that's an SRS. Okay, what's the easiest way, the most effective way, and even for the AP exam, the best way and easiest not to mess up is to do an SRS using the hat method. And it's pretty self-explanatory, but let's actually write out the steps, because when you have to design these on the AP exam, or should you have to do one for a free response, like you have to be really clear enough that another student could actually take your directions and they could go implement the survey themselves, or they could sample people themselves. So what's the hat method? Well, first thing you do is put all the individuals, or a number for each person, on identical slips of paper. Why they have to be identical slips of paper? Because when we're drawing them out of a hat, you can't have somebody's name on a huge piece of paper and somebody's name on a small piece of paper. Remember, it's all got to be fair. So put them on identical slips of paper. Place the slips of paper into a hat, your favorite Yankees hat, I'm sure, or Cubs or Sox hat. I didn't write that in directions, but you can add that. Mix them up well. I feel like I got a recipe going right here. Place it into hat, mix well, then draw the slips of paper. as you might expect with the hat method. Last step, you just need to clarify what you're going to do. So either you're going to keep the names out after you draw them, like you draw them, you put them to the side, you keep them out. Or if you're just kind of drawing them and looking at them and throwing them back in the bag, you need to say, if you leave them in, you're going to keep drawing until n unique individuals. So n is however many, say you're doing a sample of 10, until you get 10 unique individuals. Or n could be 20 if you got a sample of 20. So you're going to keep drawing until you get n unique individuals. So you just got to be kind of clear. Like, are you going to like draw people's names and leave them out of the hat, or if you're just going to like keep them in the hat because you're lazy, you got to say like, oh well, what if I draw the same person twice? You're going to say I'm going to keep drawing until I have like 25 unique individuals or 100 unique individuals, so forth. So that's the hat method. Again, that's the easiest, probably most effective way to write these designs. I'm not saying the most practical, but in terms of explaining it, that's probably the easiest because there's things you can get caught up on if we use the calculator. And then that's the next one, the technology method. So people use random integers generated by a calculator or a computer, and we did that in class too. You get math, PRB, randint. So I'll actually add that in here. For a calculator, the directions, math, PRB, randint. And then you hit the lower bound. So for the jelly blubbers, it was like 1 to 100, so our lower bound was 1, upper bound was 100, and it'll just generate random integers between there. Okay. So that's how you would do it with technology. The steps, how you would have to describe it, first thing you have to do is give each person a label. So like the jelly blubbers, they were labeled actually from 1 to 100. So make sure everyone gets a distinct numerical label from 1 to capital N. So whatever, how many people are in your population, 1 to N. Okay, so once you got everybody labeled, let me scroll down here. You need to randomize. Let's go back here. That's what I need to put on here next. So once everybody's labeled, step 2 is randomize. So you actually use the random number generator. The one we talked about in the calculator, math, PRB, randint. That'll generate those random numbers for you. So then you get n different integers from 1 to n. Again, if you get repeats, you either got to ignore them, or if repeats don't matter, then you can keep them and do that. And we'll talk about that in a second. So you can enjoy a little comic here. Those are always fun. They take up a little space in the notes, but hey, you know what? It's okay. Okay, and then the last way to generate random numbers and to make random samples is you can use the table. We have a table of random digits. Okay, so that's actually the first blank. So if you don't have technology handy, and you somehow have a table of random digits handy, like your stats book, you can have a random digit table. You can use a random digit table. And actually that's in the back of our textbook. That's on page T5. So those are the table section. So table T5. And let me show that to you real quick. So that's this right here. Turn to T5 in the back of your textbook. It says table of random digits. Table D, random digits. So here's how, if I say go to line 108, you go to line 108, and you start reading off random digits. So it's pretty simple. They already generated a bunch of random digits, and they kind of organize them in lines here, and then you could use these. You could just read off from one of these rows here, and we'll actually do that in the next example. And you could get random numbers that way and generate your sample that way. All right, so let's go back to the notes. Okay, so if you're going to read random numbers off this random digit table to pick people, first thing you got to do, and probably the most important stipulation with these random digit tables, is you got to label each person, and you got to make sure that all the labels have the same number of digits. They got to have all the same number of digits, and ideally, you're going to use as few digits as possible when you're making these labels. And let me give you the biggest example. So let's say we're going to sample 100 kids at Lake Park. So for example, you're going to sample 100 students. So one way you could do it is label each student, like the first person, since I got to have the same number of labels, or the same number of digits in each label, I could give them 0, 0, 1. And the last student, they could obviously get 100. And I would randomly sample kids from there. Okay? So 0, 0, 1 to 100. I couldn't just put 1 to 100 because the number 1 shows up way more times on that table than the number 100 does. So as long as they have the same number of digits, if you're 1, you got to be 0, 0, 1, sorry. But actually, that's not the most efficient way to do it. So I said try to use as few digits as possible in the labels. There's a more efficient way to label 100 students. So see if you can come up with that. All right, time's up. The trick is this. Well, if you want to get 100 students labeled, instead of starting at 1, why don't we start at 0? We could, instead of going 1 to 100, we could do 0 to 99 and keep the labels 2 digits long. So that's actually more efficient here. Go 0, 0, start the count there, and go up to 99. You can do it with only 2 digits in your label. But the other big key is make sure the digits at least have the same length, the same number of digits for the label. Okay, step 2. Then you got to randomize it. So here's how you do it. You read consecutive groups of digits of the appropriate length from left to right across a line in table D, whichever line it is. Ignore any groups of digits that wasn't used as a label or that duplicates a label already in the sample. And then stop when you've chosen n different labels, however many you need, whatever n is. Your sample contains the individuals whose labels you find. Okay, pretty simple. It's pretty simple. We're going to apply that too. So, if it duplicates the label, you need to state how you're going to handle those duplicates. So, if duplicates are okay with you, that's fine. But if you need like 10 people in your sample and you need 10 different people, then you need to say like, okay, if I get any repeats, I'm going to ignore them. But you just need to be clear. So state what you're going to do with the duplicates. Okay, the definition. Let's be clear about what a random digit table is. So the definition for a table of random integers. It's a long string of digits from 0 through 9 with these two properties. First property, each entry in the table is equally likely to occur. So whether you're 0 or 9, any of those numbers are equally likely to happen. So it could be any of those 10 digits from 0 to 9. So that's the first property. This is essentially how they generate them too. The other thing is this. Here's the important one. The entries are independent of each other. So they're not like the entries like in the row. I mean, you could look at the string of numbers below this example too. So they're independent of each other. That means knowledge of one part of the table doesn't give you any further information about any other part. For example, let's just say I'm reading off the table and I go like 1 and then I hit a 7 and a 7. Well, just because you got a 7 or 2 7s in a row, that does not mean the third number can't be a 7. So if you get 2 7s in a row, that doesn't mean the third number can't be 7 because they're independent. So having knowledge about the previous numbers doesn't tell you about any numbers in the future or the past or anything like that. So every single time it's a random number. That's what it means to be independent. So knowledge about one piece doesn't give you any other knowledge about another piece. Okay, so now let's actually use that random digit table. Okay, so this example about mall hours. It says the management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. I don't know why they're going to ask 3, but apparently they think 3 is good enough. So it says use table D, which is in the back of the textbook, at line 101, so they're telling you what line to start out at, to select an SRS of size 3 stores. Well, I'm nice enough that I already copied line 101 onto these notes for you, so you don't got to flip to your textbook and table D. even though I'm sure you have your textbook out and open right now. Listen to these notes. So, how do you do this? Well, here's the first issue, is this is just a list of stores in alphabetical order. So I guess the first order of business would be to actually number these stores here, give them a label, and then we'll read off from the digit table and see which ones come up. So that would be our first order of business. So since there's over 10 stores, we should not, this would be a mistake, to just start going 1, 2, 3. That'd be a mistake. So let's don't do that. Let's erase that stuff. We need to, since there's going to be over 10, let's start out and say 0, 1, 0, 2, 0, 3, 0, 4, and so on. So that's the first thing we got to do, is actually give these guys labels. So let's label all 21 stores. Doesn't really matter how you label. You want to label a different way, that's fine. You're going to get a different answer than me probably, but like if you labeled it 1, 2, 3 across instead of down like I did, I'm sure you're going to get 3 different stores. And feel free to do that. I'd be interested to see what you get. Okay, so now we got them all labeled. So let's go to the line of random digits here and start reading across. So my very first pair here is 19. So that's actually right away, that's a winner. 19, that would be Star Jewelers. How about that? So number 19, that's a winner. So Star Jewelers is going to be in our sample. Okay, good. The next number, 22. Okay, that's not on here, so that one I'm not using. Skip it. Next pair. So there's 3 and a 9, so that's our next pair of digits. I know they're separated, but still, that's how we read it. That's our next pair. So 3 and 9, that's not on here, so see you later. 50, not on here, skip it. 34, not using it. Ooh, how about this label though? 0, 5. Since I got to read by twos, 0, 5 would be my next one, so 0, 5 is winner, winner, chicken dinner, Carter's for Kids. Oh, what a great place. If you've ever been there. I haven't, but it sounds great, so I'm sure it's great. Carter's for Kids. Okay, that's one. We need one more, so keep going. 75, nope, not interested, can't use it. I can only use numbers between 0, 1, and 21. Next pair is 62. That's no good, too big, sorry. 87, nope, not in there. Looks like our last one right here, found it, 13. And now we're done. We don't have to read anymore. Got our third one, 13, so we stop. Oh, Mrs. Fields. I think that's the cookie place, right? Mrs. Fields. Okay, we got our 3 stores. So if it asks me which three I got, let's answer it in context. So the 3 stores that are going to be included in our SRS that we're going to sample. We got Carter's for Kids. We got Mrs. Fields. And we got Star Jewelers. I was really hoping for Nike Factory Outlet, but that's too bad. So we labeled them, and we read pairs of digits off this random digit table, line 101, until we got 3 that were included in our population here. We sampled those 3. Okay, so last little bit here. AP exam, common error. We already talked about this. You need to make sure that they have digits that are fair. So if you're going from 1 to 50, use 0, 1 to 50 rather than just like 1. You need to use 0, 1. And here's actually the reason. The digit 1 has a 10% chance of occurring, right? Because it's one of the 10 digits. But a 2-digit combo only has a 1% chance of occurring. That's the reason why you have to have digits of the same length. 1 has a way bigger chance of occurring than the pair 0, 1. Okay, last note here. What's the difference between sampling with replacement? So you're going to hear this. With replacement versus without replacement. The difference in sampling with replacement or without replacement. So pretty much you just have to ask yourself the question whenever you're designing the study is, do you allow repeats in your sample or not? Like if you need 10 unique individuals, you can't allow repeats. But if you're sampling something that does allow repeats, well, then that's okay. You can keep those repeats. But in particular, we just care about the one that doesn't allow repeats, because then we have to be really explicit about what we're going to do. Like if we get repeated numbers in the random digit table, or if we get repeated values in the calculator, what are we going to do with those numbers? So that's the point. So if you're not allowing repeats, then you need to say you're going to ignore the repeated values, or you need to say you're going to sample until you have in unique numbers. So you're going to ignore the repeated numbers from the calculator or the table until you get in unique individuals for your sample. That's all for these notes. I'll see you in class Monday.